Hello, and welcome to Microsoft Tech Takeoff Day 4. This is our Ask Microsoft Anything, focused on the latest in Windows hardware security. I'm Kevin Sullivan from our Windows ecosystem and commercial engagement team. Every day, I have the opportunity to work with my colleagues here to help our Windows partners build secure Windows PCs, helping customers be safe and productive. And so I'm excited to introduce my teammates who we're going to talk about Windows security with today. Harish, you want us to kick us off?
Hey everyone, my name is Harish Krishnamurthy. I'm the product lead at Microsoft here, working on Windows security, focus on data protection, attestation, and hardware security.
Awesome. And lastly, hi everyone, I'm Jordan Girton. I'm a senior TPM here at Microsoft, working on the Windows security team. I primarily work with driver security on the platform integrity space, secure boot, and I have the pleasure of working with quite a few device manufacturers as well, trying to push the latest and greatest Windows features.
Perfect. We got a great question to start us off. This one, I'm going to ask Harish to start, and then Jordan, feel free to jump in as well. The question is, how do I tell at scale which devices can support VBS, HVCI, and newer kernel protections?
Yes, so these are certainly part of our Secure Core PC. They're available in settings. Some of these are also supported through the Intune if you have the subscription. Not all of them, some of them are. The at scale would be the Intune method to actually monitor these. And it may not be available for all the features, but it's something that we're certainly looking into.
Yeah, many of these, of course, are on by default on new PCs as well. Of course, customers will want to be able to have that visibility, but on newer PCs, they will be turned on automatically.
I see the next. So what does VBS actually do at a hardware level? At hardware level, this is essentially we're leveraging the hypervisor to have isolated environments, better protection against certain executions. So at a hardware level, think of this as hypervisor is doing bulk of the work for you.
Yeah, that's great. To add on to that, like VBS, like Harish mentioned, we leverage the hypervisor and like the virtualization environment. To touch on like the driver integrity space for a second, we leverage VBS virtualization-based security to run key components like code integrity, which is the component that evaluates kernel mode ring 0 code. We run this environment in virtual secret mode in the hypervisor protected code integrity environment. So we take advantage of some of the security benefits there. Again, we check all kernel mode drivers and binaries before they're started, and we're able to prevent unsigned and untrusted drivers and kernel mode code from running.
Yeah, Jordan, I think you described it as almost this execution environment, and we've been able to, over the last many years, see more and more features in Windows be able to take advantage of that more secure execution environment. I think Hello would be another one with some things like enhanced sign-in security using that same platform.
That's a great one.
All right. Our next question shifts to TPMs. And the question is, do all TPMs behave the same, or are there differences between firmware TPM, discrete TPM, and the Pluton TPM?
Great question. I get this a lot. The TPM itself follows the TCG spec, and they're implemented pretty, uniformly across the board. The main difference comes from the way the security is exposed in terms of like for firmware TPM versus the discrete TPM. Discrete TPM, innately sitting separately as a processor on its own and talks to the main SOC or the main CPU. And firmware TPM, on the other hand, is actually part of the main SoC. It's embedded, and so it offers you the additional protection of not having to expose the bus that talks from the TPM to the main CPU because it's already embedded inside the main SoC. So you get additional protection with firmware TPM from that sense. But the discrete TPM, on the other hand, offers its own protections in the fact that it is a very isolated, at the same time has its own hardware, so it also offers its own protection from that standpoint. Pluton, this is obviously our Microsoft take on security processor. It offers a different set of privileges and security protections in terms of what it can store and how it stores information. There's a lot of features that Pluton is also a higher powered processor compared to a TPM. So that offers additional value for certain customers.
Yeah, Harish, that was a really good point at the beginning that all of them are going to conform to this TCG spec so that they're operating at a same behavior across all those implementations. The other thing that we've seen is really important is make sure customers have a plan to keep their TPM implementations and firmware up to date, no matter which of those three options they're using. All right. Our next question is, how do we verify remotely that these hardware-based protections are actually running? What kind of tools, reporting, other services do we have available for our customers today?
Great question again. I would separate that into two aspects. The first part is, how do I do this remotely? I think that's the main, that's the first part of the question. And then how do I do this for hardware-based protection? I think the answer is attestation is the first and the foremost thing that should be considered. Attestation allows you to verify and make sure this is actually an authentic piece of hardware. It has the right set of values from the time it has shipped in the factory and so forth. And that serves as the basis for how your system boots. And the rest of the protections across the software stack, those are all dependent on how the system boots and how you've actually validated and attested it through the Microsoft attestation service. So that's how you remotely verify that.
That's a really good answer. I'll also add on, like, there are a lot of levers and interfaces and management planes available for Windows customers. Almost to a fault. There could be a lot of different avenues for the measurement. So love attestation, but if you're looking to audit your environment, perhaps you're not quite ready to take the leap to attestation or conditional access. You can leverage tools and management planes like Config Manager and Intune to query states as well on the device.
All right. This next question is for Jordan. It's a topic that our teams have spent a lot of time on together over the past few years. It asks, what exactly does Secure Boot protect against, and what does it not stop?
Yeah, it's a great question. So UFI Secure Boot is a feature implemented in the firmware, and you can think of it as an allow list and deny list. The whole purpose of the feature is to provide integrity, code integrity to pre-boot components, firmware components. So the way that the feature is implemented is there's an allow list of signature authorities that we trust in the allow signature database, also referred to as the DB. And then there's a deny list of signatures or hashes of components that we no longer trust. Think vulnerable boot components, and that's implemented in the revoked signature database for the DBX. And again, the purpose, or what we're able to protect against is, again, we're able to protect against anything, boot kits, root kits, anything that should not be running pre-boot, that does not pass validation trusted components. What we can't protect against is anything that happens before the firmware environment. Like vulnerabilities like the logo failure that we had several years ago, where we ultimately required our OEM partners, our BIOS vendor partners to ship firmware fixes. So really great feature, though. Recommend turning that on at scale, and it's very timely considering the key rotation.
For sure. And I know we'll have some more questions on that. We have some great questions coming in already. I'll invite anyone who's watching us here. You can post your questions at aka.ms/latest in hardware security, and that link is going across the bottom of your screen. We're going to get to as many as we can on the AMA here, but we've got a great team of experts who are going to try to follow up with as many as possible online as well. All right, Jordan, this next question is still around secure boot. What happens if devices do not get updated with those new secure boots in time?
Yeah, it's a great question. We've had that from a lot of our partners. It is obviously very top of mind and timely. First thing I want to say, reassure devices will continue to boot, right? If you don't receive the certificate updates, devices still boot as expected. There is no risk, to boot failures. There's no concept of a system time or clock in firmware, which comes with, pros and cons, but the net is your device will still function properly. What happens if you don't receive the secure boot certificates? So Microsoft will continue trying to push certificate updates to devices well after the expiration. So we'll, even after the expiration, we'll continue to push updates. There are two types of updates, certificate updates that we're looking at. The first is the KEC. So if you don't receive a KEC update by the time of the expiration, the next time Microsoft pushes a revoked signature update list update, those devices won't receive that. So they'll potentially be vulnerable to components that we've revoked. The other certificate update list is in the allowed signature database. We're going to be pushing updates to our UEFI signer. So this is the signer that signs Linux distribution bootloaders. We also have another certificate that signs our first-party Windows bootmugger update. And so if you don't receive a certificate update by the expiration, you won't receive boot manager updates. This could leave you vulnerable to boot manager vulnerabilities. So it is imperative that you're auditing your environment, you're using our many levers to manage the secure boot updates. But again, rest assured, devices will continue to function even if they don't take those updates.
We have had an opportunity to do a couple of AMA sessions just on secure boot. I think we'll have more in the future. And you see that link there, aka.ms/get secure boot has all sorts of resources for home customers, for IT pros planning their rollouts, and links into pages from many of our OEM partners who describe the support and resources that they're making available as well. All right, our next question brings us back into VBS. It asks, can VBS or memory integrity break drivers, VPNs, or virtualization tools?
There is a part of this question. It's a good question. The VBS memory integrity, these are features built around the hypervisor. So they operate, I would think of them as operating one level below third-party drivers. I think it's also a place where I think it'd be good to sort of, Kevin, maybe talk about a little bit about our driver work that we're doing. If you want to just give a quick overview on the third-party driver protection.
Yeah, on this one specifically, I'd point to the work that we do around ensuring compatibility for customers. And so with the introduction of VBS, it did make some fundamental changes, but we worked and engaged throughout our ecosystem over years to help them prepare. And if there were changes that they needed to make, we guided them and helped them through that process. And today we're at a point where there are largely automated tests that help identify anything that may be an incompatibility between drivers, VPNs, virtualization tools, security software, and the Windows security foundations, because we have that goal that customers can choose the security software that works for them and make sure that it works well with Windows, today's security features, and the ones we'll build in the future as well.
That's a great point. And just to maybe spend a second on the co-integrity and driver side. So the process when you go to enable HVCI or memory integrity rather on a device, the first thing we do is we run the HVCI scan tool against your driver store, and we look for any known compatibility failures. So there are requirements for drivers to be able to be memory integrity compatible. And so before we enable, before Windows enables memory integrity, we verify that all your drivers are going to work after enablement. The other thing we do on the Microsoft side is we run a program where we do vendor outreach. So we work with our hardware partners to ensure that drivers are compatible with memory integrity. And we actually follow up and we file bugs on our partners and have them fix any incompatibilities. And we do this every week. So we invest in the space and we ensure that compatibility experience, the story is going to be good for our customers.
Hey, Jordan, this next question builds on that, I think. It asks, why are features like HVCI and Credential Guard enabled by default on some devices, but not others?
It's a good question. I'd love, Harish jump in as needed, but there are a lot of hardware and security requirements, different programs that we have and work with our hardware partners. Some of it's very device skew. It's very hardware partner specific with respect to our, with some of our Windows security features. And so our story is improving in the space. But again, we do work with our partners to try to push adoption of our features. Some of the features take a little bit longer to be widely adopted. But we have great relationships with our vendors. We work very closely. Again, I work with folks on Kevin's team who do a great job managing our hardware partner program, and we work with them weekly, day in, day out to again push an enablement and adoption, retention of our security features.
Yeah, no, that's a great answer, Jordan. I think it's really the flavors of different SoCs, different partners, different OEMs that we work with. It's a combination of factors, and just making sure that they all go through our pipeline in terms of validation, readiness of the feature, deployment of the feature, and so forth. There are cases I would say customers should take additional, think of how these are deployed either through your group policies or MDM as well. Those are other aspects to consider.
Yeah, I would just add it's probably the hardware profile that is the biggest driver in terms of can a device use some of those advanced security features. And it is becoming, I'll say, much more ubiquitous in recent generations. Customers on the consumer side can look to things like a Copilot Plus PC. Copilot Plus PCs have all those features available and on by default. On the commercial side, you can look to Secured Core PC for that same confidence. All right, our next question brings us right back into Secure Boot, timely topic over the next few months. And it asks, will enabling Secure Boot break imaging, recovery media, or dual boot scenarios? Jordan, do you want to take that one to start?
Certainly. Yeah, it's a great question. The short answer is most likely not, but it also might depend. And so we obviously recommend validation and testing. The great news is all 99.9% of boot media, dual boot scenarios, they're already signed by certificates that are widely trusted and deployed by Microsoft, by our hardware vendors. When you enable Secure Boot, they're built into the templates, they're built into the defaults. Now there are some caveats to that. So some new modern boot media might not be in the defaults. So once you enable, you could be enabling the 2011 version of certificates that again might not be compatible with new boot media. So, but again, this is more of an edge case, niche scenario. Again, we do recommend validating testing, and we do absolutely recommend turning on Secure Boot. Again, there are a lot of great protections that we rely on for Secure Boot, both in the firmware and early boot component space, but also in the kernel and HVCI. So, there are a lot of great benefits to turning on Secure Boot. There might be a bit of a learning curve when you first turn it on, but again, most of those scenarios should not be an issue.
For sure. And I know we're also getting some good questions in chat with some specific scenarios customers are running into. We're going to try to address some of those in the online forums so we can get you the most direct answer as possible. All right, this next question, keeping us in VBS, asks, what is the real world performance impact of VBS on modern CPUs?
I think so. The main thing to understand with VBS is it's a virtualization-based security, which means it is going to use more of the software cycles than having something that's completely in hardware. It's hardware backed certainly, but it's not completely in hardware. We haven't seen a significant performance hit related to VBS, unless you know Kevin or Jordan, but I haven't seen any significant impact on VBS performance itself.
Yeah, I've seen it be very small on most modern hardware, and it's absolutely something that we monitor on a regular basis. And so if we do see any regressions, that's something we jump on very quickly. All right, this next question asks, what happens on older hardware that is capable of running Windows 11 but can't enable all of the hardware backup protections?
Certainly there are many cases where we do actually detect the hardware, like, for example, DMA protection is one example where we actually detect if the hardware is capable of it before actually turning it on. And similarly, there's cases where we also look at the version of the TPM before implementing certain aspects.
Mm-hmm.
That's how we do it typically. Jordan, anything else you want to add there?
Yeah, for sure. We have secure boot capability requirements, minimum floor requirements for the version of the firmware running on the system. While technically you might be able to get away with running Windows 11 on a system that otherwise is not supported. Again, it's a sort of an unsupported scenario. There will be scenarios that might not function as expected. So while it's technically feasible, might not be a supported scenario. So kind of doing so, at your own risk and kind of choosing your own adventure there.
We've got less than 4 minutes left. We're going to try to fit in as many as we can for folks who are sharing us questions. This next one, what is kernel mode hardware enforced stack protection, and do we need new CPUs for it?
This is kernel mode hardware enforced stack protection. This is it's related to the memory integrity, I believe. Jordan, do you know exactly which one of this is?
I'm not super familiar with this feature. I know the team that is, so this is absolutely something we can follow up with the asker for this question. I don't want to misrepresent it, so we'll put you in touch with the right folks.
Yeah. Many of these security features really are built across the Windows team, and so we'll make sure that in the online forums we bring in the right experts for that. All right, we're going to do one last question, and I'd love a chance for both of you to chime in on it. The question is, how do we explain the value of hardware-backed security to our leadership in plain language?
This is a great question. I think the way I would look at it is ultimately key protection, data protection. These are critically important assets for users and enterprises. And one of the ways we've traditionally had is involve hardware to protect these, because it's a separate operational environment than the main software, which has a lot more code, much we refer to it as TCB, sometimes large trusted computing base. That's how it goes with software. So with hardware, you have fewer things to worry about, and you have additional protection. That's the highest, at a very simple terms, that's how I would describe it.
Jordan, anything you want to add briefly?
Yeah, I would say love that answer. To add on, like it is the foundation for modern OS security, right? With hardware-backed security, there are fewer attack vectors, there are fewer threats, versus just enabling OS or software based security features. So, the whole purpose of this this area of security is to create isolated environments, protect your devices, protect your your critical user and data stories. So
absolutely. All right. Well, we fit in a lot today. I want to thank everyone for joining today's AMA. Thank you, Harish. Thank you, Jordan. Q&A is going to remain open on the tech community through Friday, so keep those questions and comments coming. And then up next, there is a great session on Zero Trust DNS, securing Windows one connection at a time. Thanks, everyone.
Thank you so much.
Thank you.